All right. So we will be talking about topic 2.1 today. We will be going into a bit of your 2.3, your Hess's law. We'll be using a bit about Hess's law today also. And we'll be also going into your 2.2 calorimeter. Okay. So your 2.1 basically is talking about all these enthalpies. All right. Yeah, 2.1 is all talking about all these enthalpies. Very simple if you have prepared and if you have ready for it. So let's go into the exercise. Your exercise 2.1.2, where in this exercise we will focus mainly on how to write the thermochemical equation. Soalan semua ada kan? Dah buat kan? Okay. We will check the equation together. And most important thing that I want you to do is check the physical phase, check the balance equation and the delta H. Make sure you have the delta H on your answer. Okay, that makes your thermochemical equation different from your chemical equation. All right, so we'll go through one by one, and if you have any answer that is different from mine, then stop me. Okay, kalau jawapan saya salah ke, jawapan saya lain ke, then you stop me. All right, so for your A until your D semua adalah standard enthalpy of formation. All right, and just a quick question, enthalpy of formation, delta H mesti positif atau mesti negatif atau boleh mana-mana?
Boleh mana-mana.
Alright, Suran say kita boleh ada mana-mana. Because it's a heat change, therefore it can be negative. It can also be positive, depends on the question. Next question, 1 mole duduk pada siapa?
Produk.
1 mole duduk pada produk. Arif kata 1 mole of the formation mesti duduk pada produk. Yes. So for the A, you have C2H6 as your product. C2H6 gas. Therefore your element mesti adalah carbon solid. Alright, carbon adalah solid. And then you have your hydrogen gas adalah H2 gas as the element. And then your product adalah C2H6 gas. Make sure you have the delta H given written down in your equation. That is your thermochemical equation. So you have your kilojoule per mole over here. And make sure you balance the equation. Equation yang ni patut adalah 1 mole. Therefore carbon adalah 2 mole. Hydrogen gas adalah 3 mole. Agree so far? Okay. Benda yang kamu kena check selain daripada balance equation, sayang kena check fasa. Kalau fasa saya ada yang lain dengan kamu, then you let me know. Adiba share device dengan siapa?
Dengan Izwani.
Okay. Alright, you have your carbon. For the B, you have your carbon. Over here adalah C2H2OH. So kamu ada carbon, kamu ada hydrogen gas. Dan kamu kena ada oxygen gas sebab ada kehadiran O. Okay, OH kat situ. Your product, 1 mole C2H2OH. Dan dia bagi dalam bentuk liquid, and your enthalpy of formation over there guys, negative 278 kilojoule per mole. And if you look at the balance equation over here, balance the equation macam biasa, produk kena 1 seperti yang Arif kata tadi. Produk mesti 1. So carbon adalah 2, hydrogen adalah berapa? Kelas?
3/2.
3/2. Thank you Syafi. 3/2 sebab produk mesti 1. Hydrogen 2, hydrogen 1. So hydrogen yang saya nak adalah 3. So 3/2. Oksigen akan jadi 1/2. Make sense? Setuju? Thank you. Alright, thank you untuk yang mengangguk tu, thank you lah. Yang buat dek kat aku tu macam biasa, hampa kekalan dengan buat dek hampa tu. Alright, Syarifah dengan siapa sayang?
Dengan Aina.
Dengan Aina memang satu bilik ke?
Tak.
Bukan kena quarantine ke?
Lain slow.
Buatlah apa pun, just stay safe. Alright, just stay safe. That's it. Okay. So kita ada the next one. 2 yang ke bawah ni agak senang lah. 2 ke bawah ni agak senang. Just soalan yang saya bagi untuk 2 bawah ni, if you look at my answer, you realize that they cannot be in the form of ion. I hope you realize that. Nampak? Dia bukan soalan susah. Just I want to remind you that they cannot be in the form of ion because they are element. So if you look at the way that I write, look at the element. Alright, look at the element. Calcium solid, neutral. Calcium dalam bentuk solid, neutral. Fluorine dalam bentuk gas, neutral. Bukan Ca2+, bukan F-. Yang tu yang saya nak ingatkan. Because if you read the definition of enthalpy of formation is from the stable element. Okay, that is their stable element. Okay, and it's already balanced. Simple question. Yang ni tak ada isu apa. Just diorang bukan ion. Itu je. Okay, itu je yang saya nak tunjuk. And last but not least, your D for the formation also very simple. You have your calcium solid, slightly different. You have your oxygen gas. You have your hydrogen gas, your element, bukan OH minus ya. Bukan OH minus. So you have your calcium hydroxide solid. Your enthalpy of formation over here adalah positif. Soalan tak bagi positif tapi bila kamu tulis kamu wajib letak positif. Siapa yang dah buat check balik jawapan kamu. Soalan tak bagi adalah masalah soalan. Kamu bila tulis kamu wajib ada positif tersebut. Okay? Mesti kena ada positif dan check balik dia adalah calcium solid. Dia adalah oxygen gas, dia adalah hydrogen gas. Okay? Question so far? Ada isu? Tenang Alright, adakah yang tak tahu fasa dia apa? Boleh Saya bagi tahu tak? Saya bagi tahu dah kan? Fluorine, chlorine, bromine, iodine, what is the physical phase and so on. Did I? Did I? No? No? Yes? No? No? Okay, no, a quick one. Fluorine, chlorine,
Yes,
bromine, iodine, gas, liquid, solid. Apa lagi? Yang saya go by soalan lah. Soalan ni ada logam. So your group 1 metal, your group 2 metal, your group 13 metal. Contoh sodium, potassium, magnesium, calcium, your group 13 aluminium, logam kumpulan 1, kumpulan 2, kumpulan 13, logam solid. Along the way kalau saya jumpa apa-apa lagi saya bagi tahu. Okay? Oxygen gas tu, hydrogen gas tu, kalau tak tahu sila berhenti bernafas. Okay? Yang tu kena tahu lah. Alright, yang tu kena tahu lah. Okay. Next, combustion. Alright, quick question. Combustion, delta H mesti?
negatif.
Delta H mesti negatif. Thank you. Sebab heat mesti release. Okay. And next question also. 1 mole kena jatuh pada siapa?
Produk.
Produk. 1 mole kena jatuh pada produk. Tetapi adakah produk dia forever carbon dioxide atau water? The first question that I give to you over here is the example of where the product is no longer water or carbon dioxide. Budak akan selalu kata, oh combustion mesti carbon dioxide dengan air. Dia hanya akan hasilkan carbon dioxide dengan air kalau dia adalah hydrocarbon ataupun organic compound. Alright, hydrocarbon ataupun organic compound yang melibatkan carbon dan hidrogen. Kalau dia adalah logam, contoh magnesium solid. Kalau dia adalah logam, when your logam burn in oxygen, you will have your metal oxide. So what you will be formed is this one, guys. Mg2 plus, O2 minus. Remember pakcik ni? This is what we call oxide. Alright, your metal oxide, you'll be forming your MgO solid. Your metal oxide is in solid, okay? That will give rise to your enthalpy of combustion, which is negative 607 kilojoule per mole, knowing that 1 mole mesti adalah compound yang dibakar. Magnesium mesti adalah 1 mole. So over here, you need to balance based on your magnesium. In the other words, oxygen gas 1/2. Okay, setuju ke? Bukan isu apa pun. Isu dia satu je. Jangan expect dia akan dapat carbon dioxide dengan water sentiasa. Okay, itulah isu dia. Okay. And then you have your F over here. Your standard enthalpy of combustion also, yang ni senang, C4H8, tak ada isu apa. Gas. Okay, yang ni nak bagi tahu tips a bit. C1 until C4 adalah gas. C5 until saya tak ingat tapi saya rasa about 15 kalau tak silap saya, 13 or 15, I don't really remember. 13, 15 lah, saya tak ingat sangat, nanti saya check balik. Liquid. And then your C14 and above adalah solid. Kita akan biasa jumpa yang ni je. Alright, sebab kita tak belajar apa-apa yang lebih daripada C10. Alright, kita jarang jumpa benda yang lebih daripada C10. Sebab tu saya tak ingat dia C berapa belas. So kalau dia C1 sampai C4 dia gas, kalau dia C5 dan ke atas dia liquid. So kita nampak kat sini C4H8. Kalau soalan tak bagi tahu pun kamu tahu dia adalah gas. Okay, that is the way lah. Plus with the oxygen gas, then you will be forming as always your carbon dioxide guys, gas, plus your H2O. And guys, H2O liquid. H2O kat sini mesti adalah liquid sebab standard condition. Dalam keadaan sekeliling kita, 25 degree Celsius, 1 atm, air kamu dalam keadaan apa? Liquid atau vapor? Kalau vapor hebat kamu minum air dengan nafas macam ikan pula dah. So dia adalah liquid. Okay, dia adalah liquid kat sini. And balance the equation. Balance equation ni senang je, C4. So 4 carbon dioxide. H8. H2. So bagi 2, H8 bagi 2, 4. Okay. That is the way that we balance it. And then balance the oxygen. I have 8 oxygen over here. I have 4 oxygen over here. I need 12 oxygen. Therefore 6 O2. Okay. Setuju setakat ni? Check phase ya. Gas, 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 liquid. Okay.
Ya, madam.
Yes. Yes, Arif? Okay. All right, your G over here and standard combustion of C2H6O. Yang ni patut liquid ni. Dalam soalan kamu pun gas kah? Dalam soalan kamu pun gas kah?
Yes, madam.
Okay, tak apa, gas pun gas lah. Patut liquid lah. Normally when it's alcohol, we will normally put down
Yes,
as liquid.
yes, madam.
Yes? Soalan? Kalau line tak okay nak tanya soalan boleh letak kat chat. Okay. Over here 2, 3, 7, over here 3. Correct me if I'm wrong. Betul ke? Setuju? Okay. Okay. Ngangguk. Okay. Alright, that is your combustion. Just a quick recap of your combustion. Dia mesti adalah negatif sebab dia mesti heat release. Dia tak semestinya hasilkan carbon dioxide and water. Dia boleh jadi logam oxide. Dia boleh jadi metal oxide if you are only burning your logam. So cara nak dapat produk untuk logam oxide is looking at the charge and looking at the charge of the oxygen. Balance it, that is your product. Okay? Balance this thing, that is your product. Okay? And if you are getting your hydrocarbon, then product mesti adalah carbon dioxide and water. Water mesti dalam keadaan liquid sebab dia dalam keadaan standard. Okay. Alright, berhati-hati ya, bukan vapor, bukan wap air. Okay, bukan wap air. Okay. Alright. Next. Enthalpy of neutralization. Standard enthalpy of neutralization, sorry. Standard enthalpy of neutralization kat sini adalah heat release. Sentiasa adalah heat release sebab tu dia sentiasa adalah negatif. Quick question, 1 mole jatuh pada siapa?
Water.
Water. okay, a bit of tips since we are moving into your acid and base. Kalau dia adalah acid ataupun kalau dia adalah base, semua acid and base mesti adalah aqueous. Semua acid and base mesti adalah aqueous. Okay? Semua acid and base mesti adalah aqueous. So we balance it. You need the presence of your water liquid. And garam yang terhasil adalah K2SO4 aqueous. Garam yang terhasil pun adalah aqueous. Make sure you put down the delta H neutralization, negative kilojoule per mole. Okay, balance the equation. Semua orang tahu macam kawan kamu cakap tadi, water kena 1 mole. Okay, so if I balance this equation and water need to be in 1 mole, that means I will have half of this, half of this. Betul ke? Setuju ke? Balance. Kan? Okay, alright, saya pun buat terus macam biasa, hampa tahu kan perangai saya. So kalau jawapan saya salah macam biasa, kita betulkan lah. Alright. So the next tips that I can give to you over here, selain daripada your fluorine, chlorine, bromine, iodine tadi, logam-logam kamu, semua acid and base adalah aqueous. Kita takkan jumpa acid and base yang liquid. Okay, semua acid and base adalah aqueous. Liquid, water masih adalah liquid, garam yang terhasil adalah solid in this case. Okay, saya tahu kita ada garam yang solid, tapi in this case dalam neutralization garam adalah aqueous. Alright. Okay, can anybody tell me in the enthalpy of atomization? Alright. Kenapa dia mesti positif?
Sebab energy required.
Sebab energy required. Thank you, Afif. Afif kata sebab energy required. Why energy is required then?
To form 1 mole of gaseous atom.
To form 1 mole of gaseous atom, yes. So, if that is the case, I'll show you for the magnesium first. Okay, if the magnesium, I believe your equation looks something like this. Am I right? What is the changes that you can see on the equation? Phase.
Change of
Daripada
state.
solid jadi gas. Betul? Alright. Untuk nak detailskan lagi soalan saya tadi, saya tanya kenapa positif. Afif jawab, oh sebab energy required untuk form 1 mole of gaseous atom. Hang pun bacalah balik nota tu kat aku. Sister yang apa ni. Alright, tanya sebab nota ada duduk depan mata. Woi, soalan saya lagi detail yang saya nak. Macam ni lah. Saya ada reactant, saya ada product. Kalau data H saya adalah positif, reactant is more stable or product is more stable?
Reactant is more stable.
Zayun say reactant is more stable. Zayun, can you explain a bit more why reactant is more stable?
Because magnesium exists in nature in solid form, which is more stable instead of gas form.
Zayun used the statement of my explanation where energy is required to form 1 mole of gaseous atom, that is my gaseous atom, from its element. And what Zayun said is correct. That is the element. Element is what exists naturally occur. Betul? Dia wujud semula jadi macam tu. Aku tak buat apa, dia memang wujud macam tu. Dia stabil gila. Alright? Yes, correct. Your reactant is more stable and your product is less stable. In this case, you can see that because that is element. What happened kalau saya patah balik, I have this thing over here. I have a negative. I have a positive. I have a negative. I have a positive, Zayun. Both are from the element. Right, Zayun? So in this case, all right, so in this case, my negative. We look at the negative first. My negative represent the reactant is more stable or the product is more stable. Anyone?
Product is more stable.
Product.
Product pula more stable. Okay. So product is more stable. Alright, why product is more stable? We go for something very logic. Do you know what is negative stand for? Energy release, remember? Betul? Energy release. Energy release over here means, kalau asal saya ada 100 kilojoule guys, asal kita ada 100 kilojoule, dan saya tak habis guna pun tenaga tu. Saya hanya guna maybe, tak boleh 100 lah, asal saya ada 1500 kilojoule. Dan saya hanya guna about 280 kilojoule je. Yang lain ada lebih dan saya bebaskan. Yang lain ada lebih dan saya bebaskan. Bermakna produk ini terhasil, alright, produk ini terhasil dengan tenaga yang cukup sikit. Alright, dia tak guna pun tenaga yang saya ada 1500 tu. Dia hanya guna 280, lepas tu yang lebih dia bebaskan. Bermakna produk ni senang untuk dihasilkan. Agree? Alright, easy to be formed. Kalau dia senang terhasil sebab dia more stable. Alright, sebab dia more stable. And Zayun, if you want to ask why the element is less stable, why the element is less stable? Is every element that exists in this world stable? No. Fluorine gas is extremely explosive. Alright, contoh lagi, sodium. Pernah main dengan sodium, logam sodium yang cikgu kamu masuk dalam air, lepas tu dia berpusing kat beaker tu, betul? Alright, are they very stable? They are not that stable. Cuma diorang wujud semula jadi macam tu. Kadang-kadang diorang lagi stabil sebab diorang ada partner lain. Okay? So, whenever you have your delta H positive, whenever you have a delta H positive, that means you need energy to produce the product. Alright? When you need energy to produce the product means you are forcing the product to form. You force this to form. Okay? When you force this to form, that means your product will be less stable. Kalau dia adalah endothermic, anytime when it's endothermic, bila-bila masa dia endothermic, bermakna produk dia adalah less stable compared to your reactant. Sebab produk adalah something yang aku kena paksa dia untuk dihasilkan. Sebab aku kena bagi tenaga, aku kena paksa, aku kena buat something baru dia terhasil. Okay, that is your endothermic. Tapi kalau exothermic terbalik. Kalau exothermic aku tak buat apa pun, dia jadi. So produk senang nak terhasil lah. Okay. Same thing over here, your atomization of your bromine. The tips that I given to you just now. Bromine element, Br2. Gas, liquid, solid, aqueous. Liquid, thank you Fazana. Liquid, and you are forming your bromine gaseous atom. Your enthalpy of atomization sekali lagi adalah positive and is my equation balance. No. Can I put 2 over here?
Half on bromine.
Kenapa half on bromine, Afif?
No. Sebab dia nak enthalpy atomization ni dia form 1 mole gaseous atom.
1 mole of gaseous atom. Okay? Nampak? Alright, kita akan buat soalan lepas ni sikit je lagi. Ada I think 2-3 more question dan kita akan masuk soalan. Kita akan masuk soalan di mana kamu akan nampak pentingnya equation kamu nanti. Okay, you'll see this later. Okay? Alright, next. Soalan few more. Okay? Hydration. Hydration senang malah nak cakap. Hydration, apa yang berubah sayang?
Gaseous kepada aqueous.
gases to aqueous. Betul? Gases ion to aqueous ion. Yang ni senang gila. I minus gas jadi I minus aqueous. Di mana delta H hydration akan jadi negatif kat sini. Dan sayang, negatif. Soalan saya satu je. Siapa lagi stabil? Gas or aqueous?
Aqueous.
Aqueous more stable. Alright, aqueous more stable. So same thing over here. I have my potassium gaseous ion to become hydrated in water, become potassium aqueous. Delta H hydration sentiasa negative. Alright, delta H hydration sentiasa negative because your aqueous ion is always more stable. Okay, ingat ya, kalau dia negatif bermakna kita tak payah buat apa. Sayang, dia ada tenaga yang lebih. Bayangkan saya tak payah buat apa dan produk tu terhasil dengan tenaga yang berlebihan dibebaskan. Bermakna saya bagi RM100 tapi kamu guna RM50 dan hang keluar dah. So saya tak payah paksa pun kamu jadi dan kamu terjadi. So produk memang lebih stabil. Okay? Simple. Yang ni tak ada apa. Balance pun tak payah. Pay very close attention to the ion only. We will be using this a lot later. Okay? In today. So make sure you know that hydration adalah gases tukar kepada aqueous. Next. Solution. Yang ni pun kita akan banyak guna. Yang hujung-hujung ni kita akan banyak guna hari ini. Okay. Solution boleh jadi positif. Boleh jadi negatif. Take a look. This is where I will ask more about siapa stabil, siapa tak stabil nanti. So going to your M, tak ada apa. I have my NaCl solid changing to become my Na plus aqueous plus my Cl minus aqueous. Balance equation dah, delta H solution. Okay. Soalan saya yang pertama untuk garam pertama. Garam pertama kita adalah NaCl. Sayang, delta H positif 4 kJ per mol. Saya nak tanya, garam ini lagi stabil sebagai garam atau lagi stabil sebagai solution?
Lagi stabil sebagai garam.
Dia lagi stabil sebagai garam. Kenapa dia lagi stabil sebagai garam? Sebab saya perlukan tenaga untuk larutkan dia. Sebab tu, kalau garam tu tak perlu tenaga untuk larut, garam yang mak kamu beli kat rumah letak kat dapur tu, sat je semua dah cair-cair. Bayangkan garam tu adalah endothermic negatif, kamu tak payah buat apa pun garam tu cair. Hang rasa garam yang hang beli kat Tesco tu duduk dalam keadaan biji ke duduk dalam keadaan air? Nampak tak? Okay, nampak tak? Dia tak perlu tenaga yang banyak, dia kena tenaga sikit je. Kamu ambil sikit, panas sikit pun dia akan larut. Alright, kamu sentuh dengan tangan, letak dalam tapak tangan, hang golek-golek pun dia akan larut. Tapi yang penting, dia still kena tenaga. Alright, kalau dia tak perlu tenaga, garam yang kita beli kat Tesco bukan dalam keadaan biji sayang. Garam yang kita beli kat Tesco, Tesco dah tak ada. We have Lattice nowadays. Come on, Miss Wong, who goes to Tesco? Solid? I miss Tesco. Tesco is from the UK. Lattice is from Thailand. And I miss Tesco. That's it. Bye. I miss Tesco. God's sake. Orang yang paling sedih bila Lattice buy over. Saya. Alright, you have your solution. And where we are, negative 37 kJ per mole. Same thing. Equation tak ada isu. Equation ada isu kah? Tak ada kot nah. Equation solid jadi aqueous. Betul? Tak ada isu lah. Saya satu je saya nak tanya balik kepada tu. Garam lagi stabil, lithium chloride lagi stabil sebagai garam atau lagi stabil sebagai solution?
Solution.
Solution. Lagi stabil.
Yang ni more stable. Nampak? Nampak? Faham tak kenapa saya tanya positif negatif tu? Okay, so that you know which one is actually more stable, which one will actually easier to be formed. Okay, last but not least, your magnesium bromide over here. Again, your solid. And then you have your magnesium 2 plus aqueous forming your 2Br minus aqueous. And then your delta H of solution adalah negative 186 kilojoule per mole. Soalan ni bukan nak tanya apa, soalan ni nak tanya satu je. Siapa patut pegang 1 mole? Bila kamu balance, siapa patut pegang 1 mole?
Solid. Reactant.
Reactant, magnesium bromide. Okay, senang. Nampak dah how to see the positive negative? Okay, how to see the positive negative? That is how we see the positive negative. Okay, alright, yang ni. Equation saya boleh tunjuk dengan cepat, cuma yang ni kita nak masuk kepada explanation a bit, so make sure you listen very carefully and pay very close attention. Your ionization energy is when 1 mole of gaseous atom, mesti dalam keadaan gas atom, dia akan hasilkan gaseous ion plus 1 electron. Okay, that is your first ionization energy, which is positive 590 kilojoule per mole. Okay, what is mean by second ionization? Second ionization adalah kita nak buang elektron kedua. Nampak bahasa saya bukan nak buang 2 elektron. I'm not removing 2 electron. I'm removing the second electron. That is my first electron. So second electron bermakna saya akan mula dengan calcium gases ion, jadi calcium 2 plus gases plus 1 electron. Still 1 electron. Nampak ke? Still 1 electron. Okay. That is my second electron. Elektron pertama, elektron kedua. Nampak beza? Bukan buang. Sorry, Arif?
1180.
1 tu kosong.
1180.
Tak faham. Tak dengar.
Dia ada second I.
Second IE tu?
Second energy. Second ionization tu jawapannya 1150 ke 1180?
1150.
50.
Soalan saya 1150. Soalan kamu? Sama kan Ali? Sama kan? 1150 kan?
Saya tahu tulis. Okay.
Alright. Okay, apa yang saya nak tunjuk kat sini? Nampak tak beza kalau Miss Wong hanya bagi IE of calcium? Kalau Miss Wong hanya bagi IE of calcium, contoh ya, kalau saya hanya bagi IE of calcium and then saya bagi 1740 kilojoule per mole. Okay? Kalau saya hanya bagi IE of calcium tapi dia tak bagi tahu first or second. Dia tak bagi tahu first or second, dan kita boleh tulis terus sekaligus jadi calcium 2 plus. Nampak tak? Buang 2 elektron. Okay, nampak? Nampak beza? Tapi bila dia adalah first and second, bermakna kita akan tunjuk elektron pertama yang dibuang, elektron kedua yang dibuang. So elektron kedua yang ni yang penting. Elektron kedua kamu kena buang, elektron kedua hanya boleh dibuang selepas elektron pertama dibuang. Bermakna elektron kedua kena mula dengan calcium positive gas. Nampak? Your second IE kena mula dengan calcium positive gas. Nampak beza tu? Okay? Alright, boleh ya? Next question. IE mesti positif. If you read your notes, if you read your definition, you realize that your ionization sentiasa energy required. Betul? So soalan saya, jangan jawab energy required kat aku ya Afif. Soalan saya, kenapa sentiasa positif, kenapa sentiasa energy required? Anyone?
Sebab reaktan dia lagi stable.
Syarifah, sekali lagi Syarifah.
Sebab dia punya reaktan tu lagi stable.
Sebab reactant dia lagi stable. Tak salah. Slightly different. Alright, about ionization energy slightly different. Saya bagi tips sikit.
To break the force of attraction
Minri?
between electron and energy absorbed to break the force of attraction between electron and nucleus.
Force of attraction. Thank you, Minri. The word force of attraction adalah keyword. I don't know whether you remember this thing or not that you learned in your first semester topic 2, Bohr atomic model. Ingat tak pakcik ni? Kamu ada nukleus, betul? Dan dalam nukleus ada apa sayang? Ada positif. So dalam nukleus ada positif, elektron duduk kat luar ni. Betul? So elektron yang duduk kat luar akan experience one thing. What do we experience? We experience force of attraction. Betul? So when you experience force of attraction, bayangkan ionization energy is the energy required to buang this electron. Aku nak buang elektron ni keluar daripada petala ni. Saya ada nukleus. Elektron saya tertarik dengan nukleus saya. Sebab satu positif, satu negatif. Dia tertarik. Sekarang saya nak buang elektron yang ada daya tarikan tu, yang tertarik tu, saya nak buang elektron tu. So you always need energy. Okay? And why do you always need energy? To overcome the force of attraction. Okay? Like what Minri said. To overcome the force of attraction. Okay? And next question. Kalau Miss Wong ada IE3, kalau kita ada ionization 3, saya nak buang elektron ketiga, third IE. Okay? I will have my calcium 2 plus gas. Saya nak jadi calcium 3 plus gas plus the third electron. Soalan saya, this positive value will be bigger or will be smaller, or it will depends on the question. What do you think?
Will be bigger.
Bigger. It will always be bigger. Betul Syarifah?
Yes.
Okay, it will always be bigger than your second IE. Logik je weh. Kalau asal saya ada 10 proton, tarik 10 elektron. Okay tarik hang 10 kan. Hang pun tarik tak ada hal lah. Hang pun tarik tak ada isu. Lepas tu hang dah buang 1. So 10 proton, tarik 9 elektron. Hang tarik kuat lah. Betul, hang dah buang 1, hang tarik kuat lah. Sekarang saya ada 10 proton, tarik 8 elektron. Tarik lagi kuat ke tarik lagi lemah? Mesti tarik lagi kuat, betul? Bila kamu tarik lagi kuat, the force of attraction is higher, is stronger. So you will automatically need more energy to overcome it. Kenapa saya ajar balik benda ni? Kita belajar benda ni kat topik 2 semester 1. Betul? Dan dia boleh tanya balik. Dia pernah keluar di objektif dan dia keluar balik statement ni, you should know kenapa ionization energy, the force of, kenapa ionization energy forever increase. Okay? The reason is because the nucleus force of attraction. Okay? You know this. And just make sure you recall this man. Alright? Ingat balik dah? Okay, moving on a bit. And the last thing of this equation before we move on to something, some calculations, something new for you. We have lattice energy. Okay. Lattice energy over here tak ada apa, tapi dia mesti adalah daripada Gaseous ion or aqueous ion? Anyone?
Gaseous ion.
Gaseous ion. And my question, 1 mole kena jatuh pada siapa? Batrisha?
Compound. Solid
1 mole
ionic
kena jatuh pada produk atau reactant?
product.
Produk. Okay. 1 mole kena jatuh pada produk magnesium chloride solid. And your delta H lattice adalah sentiasa negatif juga. Okay, your delta H lattice pun sentiasa negatif. And since Batrisha say 1 mole kena jatuh pada produk, therefore Cl minus mesti 2. Okay. Tak sabarnya nak jumpa hampa face to face, lepas tu boleh baling marker. Petang-petang ni aku rasa ramai lainer dah ni. So kena start panggil nama. Betul Syaidan?
Ya, Miss.
Syaidan ada? Syaidan bernafas lagi Syaidan?
Syaidan
Alright.
ada, Miss. Ada.
Good. Okay. Question so far? Boleh? Senang Kita akan tengok yang ni lah. Kita akan banyak guna equation ni. Then we are moving to your exercise. More exercise, a bit of calculation. Calculation ni bukan apa. Calculation ni tak susah pun. Calculation ni saya bagi sebagai latihan untuk ingatkan balik when you are doing comparison. Okay? When you are doing comparison in equation, can we use the gram? Can we use gram to compare? No. Fazana say no. Fazana don't. No. So Fazana, what can we use to compare?
Mole.
Mole. Soalan ni bukan soalan baru dan dia bukan soalan yang so-called kamu tak boleh buat. Soalan ni hanya sebagai latihan untuk remind you one little thing. The one little thing is every comparison must be in mole. Tak kisah dia bagi mass, dia bagi volume, dia bagi apa benda mak nenek pun, sayang benda pertama tukar pacik tu kepada number of mole. Okay? So how do we change the mass to mole? Very quickly, we have molar mass. So molar mass of your N2O5. Anybody can give me the molar mass of N2O5? Hello. Syaidan? Syaidan, Olivia, 1 second.
108.
108. Okay. 108 gram per mole. Is my internet okay?
Yes,
Class,
Miss.
is my internet okay? Saya perasan tiba-tiba because my phone went into low battery mode, so it disconnect from my own Wi-Fi and jump to the KMPP Wi-Fi. Do I need to reconnect to my own Wi-Fi? Is everything okay?
Yes, Miss.
Suran,
For now,
my
okay, Miss.
still smooth?
Yes.
Smooth lagi ke? Saya tak perasan, saya baru perasan sebab dia keluar notification. Minro, is my line okay still? Just give me 1 second. I'm so sorry, just my phone jumped into that, you know. All right. Am I still in there? Am I still in there? Hello.
Yes, madam.
Thank you,
Yes,
Olivia.
madam.
Thank you. Is it better in some way?
Yes, miss.
Madam.
Thank you. I didn't realize that my phone was in low battery mode. Sorry. Just, yeah, you know. Yeah, back to this question. Tak ada apa. So you just basically change the mass to the number of mole, and then from that, you just compare from what you need. You need the N2O5. So we compare with the N2O5. Okay, that's it. So from here, from the equation, you can see from the equation 2 mole of your N2O5 were absorbed 110 kilojoule. Okay, right now I don't have 2 mole. I only have 0.1 mole of your N2O5. Ada masalah dengan darab silang? Aina, can I have the answer? Aina, Safia. Your mic. Baru nak kira. Zulaika?
Yes, madam.
Can I have the answer?
5.5.
Zulaika bagi jawapan 5.5. Anybody want to add anything?
Kilojoule.
Kilojoule.
Kilojoule. Syafiq kata kilojoule. Lagi? Tak puas hati lagi ni?
Positive.
Positive. Thank you. Kind reminder. Very kind reminder. Positive and unit. Positive atau negative kat sini wajib to show that whether the heat is released or the heat is absorbed. Whether it's endothermic or exothermic, kalau soalan nak tanya the product is more stable or the reactant is more stable, etc. Positive, negative wajib. Okay, Zulaika? Alright, and everyone lah. Okay, and everyone. Okay. Nothing big deal. To be very honest, soalan ni bukan soalan apa pun. Soalan ni saya nak ingatkan satu je. I want everything compared in number of mole. That's it. Okay. Sebab yang ni kalau keluar, kamu patut tahu nak buat sebab benda ni adalah soalan SEM 1 kamu. So tak patut jadi masalah. Okay, it shouldn't be a problem. A quick one over here. Your 3A disebabkan
Madam.
Aina tak ada. Sorry?
Madam, I have a question.
Yes, question?
Why for some thermochemical equation, there's no kilojoule per mole behind the enthalpy reaction?
Alright, when do we need kilojoule
Like-
per mole? So rain question is, when do we need kilojoule per mole? We will only need kilojoule per mole when we are comparing the thing to 1 mole. In the other words, most of the time we will write the answer in kilojoule per mole when we are talking about the 8 enthalpies that we learned, right? When we know, let's say, if you are comparing enthalpy of combustion, you know that standard enthalpy of combustion or enthalpy of combustion is comparing 1 mole of the compound that is being formed. That compound is being burned completely. So you know that is the 1 mole that you are comparing. In this one, is there any enthalpy? No. And do we know that we are referring to which one should hold 1 mole? No. Right? Sebab kita tak tahu dia apa pun. So kita tak boleh nak compare siapa patut pegang 1 mole. That's why we don't know whether the delta H over here is with respect to 1 mole or not. Right? Therefore, we cannot put in the 1 mole. Okay? That's why we cannot put in the 1 mole. Alright? So, next. Disebabkan Aina tak jawab lagi, so saya pun malas nak bagi jawapan. Saya bagi jawapan akhir je lah. Jawapan akhir you all dapat apa? A. Saya Datuk? Saya duduk kat rumah lagi ke?
Tak, dekat college.
Oh, tapi belakang nampak gila macam rumah makan. Okay, anyway. Jawapan?
Negatif 21.2 kilojoule.
Saya dapat negatif 21.2 kilojoule. Yang lain setuju? Saya setuju. Naili, okay?
Okey, setuju.
Alright, good. Tak nak tunjuk sebab ada orang tak buat dan saya tertangkap. So, tak nak tunjuk, tak jadi nak tunjuk. Yang saya nak tunjuk betul-betul adalah sebenarnya soalan 4 dengan 5. Dan dalam soalan 4 dengan 5, kita sebenarnya akan masuk a bit about Hess's law. Partially about Hess's law. Partially. So, apa yang saya ajar di soalan 4 dan 5, make sure you listen very, very carefully sebab saya akan jumpa balik hari Rabu di Hess's law. Okay? So, make sure you learn this very carefully. So, saya nak masukkan juga kat sini sebelum saya masuk calorimeter sebab soalan dia adalah banyak menggunakan equation yang kita belajar. Why I slot in this question? Why don't I discuss this under Hess's law? Very simple thing because I want you to remember the importance of the equation. Okay? There is a lot of new things that we are going to learn. Make sure you listen very carefully. If you have any questions, stop me and ask. Okay? So first and foremost, if you read the question very carefully, the question asking for the enthalpy of solution. Soalan tanya delta H solution adalah berapa? Soalan bagi lattice energy. The question give you delta H lattice. Guys, lattice energy forever positive or forever negative? Ataupun boleh positif, boleh negatif. Oh, lupa dah.
Negatif.
Dia boleh dua-dua ya. Lattice akan depends pada soalan, dia boleh dua-dua, betul? Betul ke? Ke saya salah?
It says heat release Datuk.
It say heat release.
Negatif.
Okay. So negative. Negative, I think negative. So be very careful over here. Soalan bagi lattice energy sahaja. But we know that the lattice energy must be negative. So you must have your negative 690 kilojoule per mole. Yeah. Okay, dia bagi value je ni. Equation semua tak ada tau. And then yang bawah baru dia bagi equation. So how do we start? Okay, the question is, aku nak mula macam mana ni? Saya nak ajar cara yang untuk saya cara yang senang for this question. Ataupun Hess's law ada dua cara. Satu guna energy cycle, satu guna algebraic method. Untuk yang ni kita nak guna energy cycle. Alright, saya nak guna energy cycle. So, how do I start energy cycle? Simple. Always start with what we want. Sentiasa mula dengan apa yang kita nak. Okay? Yang saya nak adalah enthalpy of solution. And this is where the importance of writing your equation come in. Enthalpy of solution, if you remember and if you understand how to write the equation very, very carefully, you realize that enthalpy of solution adalah 1 mole of your substance, solid, completely dissolved in water. So KCl solid akan jadi K plus aqueous tambah dengan Cl minus aqueous. Agree? And imagine you don't know how to write this. You don't even know how to start. Okay? Always start with what we want. Sebab yang tu yang kita nak. Mulalah dengan apa yang aku nak. Okay? Next. Okay? Next. Pergi kat tempat kosong kertas kamu. Alright? Kiri, kanan, atas, bawah kat tempat conteng kamu. Alright? Tempat conteng. Pergi kat tempat conteng. Kita conteng lattice energy. Alright? Kita conteng lattice energy. What is the equation of lattice energy? Gaseous ion forming solid ionic solid compound, betul? So gaseous ion kita apa? Gaseous ion saya K plus gas tambah dengan Cl minus gas, gaseous ion forming my solid ionic compound. And that is my lattice energy. Agree? Okay. So, apa konsep energy cycle? Sangat senang. Satu je konsep energy cycle. Dua. First and foremost, we need to form a cycle. I'll show you how to form a cycle later on. Second, there is no repetition things in the cycle. Benda yang sama tak boleh repeat. Apa maksud Miss Wong benda yang sama tak boleh repeat? Kita tengok saya ada KCl solid. Nampak? Dalam lattice energy pun ada KCl solid. Agree? Dan kita tak boleh repeat KCl solid dua kali. So we are going to use this KCl solid and pay very close attention to the arrow. The arrow of the lattice energy menuju ke KCl solid. Okay? So my arrow is towards KCl solid. Nampak? Agree setakat ni? So KCl solid untuk lattice adalah daripada K plus gas tambah dengan Cl minus gas. And then the value saya dah ada, negative 690 kilojoule per mole. At this moment, agree with what I have on the screen? Boleh kah? Are we still on the same page? Boleh? Can I move on? Nampak? Ada tak faham? Tanya tau. And next, kalau kita nak move on, do you remember I say we are forming a cycle? Is this a cycle right now? No. If you look at it, my cycle is only partially. Tak tutup lagi hujung. Betul? Tak tutup lagi hujung. So how do I form a cycle? Definitely using what I have. The next thing that I have, gas, that I have, forming aqueous, forming aqueous. And ladies and gentlemen, macam biasa, tengok arrow. Tengok arrow menghala ke siapa? Arrow menghala ke aqueous. Jangan terbalik sayang, arrow akan memainkan peranan yang penting kat sini. So arrow menghala ke aqueous. Aqueous, gas. So arrow menghala ke atas. Setuju? Okay. And value dia adalah negatif 672.8 kilojoule per mole. Alright. Boleh ke kelas? Dah? Can we continue? Setakat ni boleh? Lukis, buat, jangan tak buat. Okay, at this moment, alright, setakat ni lah. I hope you can see the importance of your equation. Alright? Imagine you cannot write the equation. You don't remember how to write solution. You don't remember how to write lattice. Boleh jawab ke soalan ni? You're done. Alright? That's why I say the very first thing that you need to do when you can write the equation, everything else is easy in this chapter. Okay? And next thing that we are going to do is your cycle, or I would call it mathematic-wise as a vector. I don't know whether you have learned vector or not in your maths. Have you learned vector? Pernah dengar vector? Okay, good. Suren say yes, so I suppose yes lah. Yang lain tak pernah dengar tu, aku tak tahu hampa duduk kat sekolah yang sama dengan Suren ke tak. Vector is something like this. The very important thing about vector is forming a circle. Or in our language, we call it forming a cycle. Nampak cycle-nya? So cycle dah ada, setuju So macam mana nak buat vector? Senang je. Kamu kena tentukan siapa yang kamu nak cari. Kalau arrow ini adalah arrow yang saya nak tahu arrow ni berapa. Okay? You identify the arrow that you want, and then what you need to do next is you are going to change the rest of the arrow. Kamu kena tukar arrow yang lain untuk bertentangan. Apa maksud bertentangan? This is bertentangan. Bucu arrow jumpa dengan bucu arrow, that is bertentangan. Okay? So what we need to do is, this arrow tak bertentangan. So kita ubah jadikan dia bertentangan. This arrow tak bertentangan. Kita jadikan dia bertentangan. Nampak setakat ni? Okay? So we go back to which one is the one that we are looking for. If you remember, this is the one that we are looking for. That's why I say, always start with what we want. This is the one that we are looking for. Okay? Yang ni tak payah ubah sebab yang ni yang kita nak. Apa yang kita kena buat? Check arrow lain. Sayang, adakah arrow ini bertentangan sekarang? Bucu jumpa bucu? Okay? Alright, agree? Nampak ke bucu jumpa bucunya? Syafiq okay? Setuju Bucunya jumpa bucu. Setuju tak? Dia jumpa bertembung. Lawan. Betul? Beres lah. Done. Tak payah ubah apa. Yang next. Yang ni pula. Lattice energy. Bucu jumpa bucu tak? Tak jumpa? Alright. Bucu tak jumpa bucu betul. Dia ikut ekor belakang dia. Dia ikut je kan. Dia ikut je. So this is not what we want. Kita tak nak. Kita nak dia lawan. Kita nak dia jumpa. Betul? So macam mana nak dia jumpa dan macam mana kita nak buat dia lawan? Senang je. Kita terbalikkan dia. Perlu lukis balik tak? Jangan bazir masa weh. Dalam exam pun sama. Ni saya buat cara exam ni. Dalam exam, padam je. Tak payah guna correction tape pun. Padam je guna pen. Padam je guna pen, letak arrow kat sini. Nampak? Dan yang paling penting, boleh tak kita hanya ubah arrow tapi value tak ubah apa? Kalau arrow berubah, apa jadi pada value?
Magnitude changes.
Positif.
From the negative become positive. Sama. Tak payah guna correction tape. Tak payah nak tunggu dia kering. Tak payah duk tap nak tunggu dia kering. Hang guna pen hang potong je. Hang tulis balik positif 690. Habis cerita. Alright? Dan jangan lukis balik. You don't have time. Aku cukup nyampai bila budak nak lukis balik sebab satu arrow tu. Tak payah. Okay? And that is what we call vector. And when you are done with the vector, how do you solve the mathematics? Simple. Arrow yang bertentangan yang kita nak, akan dijadikan perkara rumus. Delta H solution will be equals to semua yang bertentangan dengan dia. Will be equals to hasil tambah semua yang bertentangan dia. Negatif 672.8 kJ per mole. Tak payah letaklah kilojoule per mole tu, nanti kita letak. Alright, tambah dengan positif 690. And bila saya kata tambah sayang, perasan tak saya ambil kira positif negatif? Kena ambil kira. Okay, and you solve the mathematics. When you solve the mathematics, you realize your answer is dapat berapa? Soalan saya, positif atau negatif?
Positif.
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 Next question. Unit? Enthalpy of solution. Suran?
Kilojoule per mole.
Kilojoule per mole, because it's an enthalpy of solution. We know that the 1 mole is over here. See that? Clear? Okay. And value? Yang ni kita bagi chance. Ni senang, saya dah bagi dah, tunggu kira je. Aina Safia?
70.2.
17.2. Kelas 7? Senang? Senang? Alright, benda yang kamu tak biasa buat, kamu biasa buat kat maths sebagai vector. Okay, I know that is quite messy over here, but if you follow me from the beginning, you should be able to get it. Okay, just a kind reminder, make sure you can write the equation. First thing, make sure you can write the equation. Second thing, make sure every single time when you change the arrow, every single time when you change the arrow, the value also change the sign. Okay, and last but not least, make sure you know how to solve a vector. Apa maksud arrow bertentangan? Okay, make sure you know how to solve the vector. You learn vector in this semester or last semester? Or do I learn vector?
SPM.
Oh, you learn in SPM, then you must be very good. I thought you are the best batch of SPM in Malaysia. Result gempak gila-gila. So you must be really good in your vector, right? Oh, we can move very fast then. Miss Wong, kalau sarcastic, Miss Wong number 1. I don't see how good you are in your SPM. Guys, all that is your beautiful lies. You know what people call white lies? All right, do we have white lies in BM? What do we call white lies in BM? Yes, Adiba?
Tak mesti tekan nak zoom.
Oh, tertekan ingatkan hang setuju. Saya setuju Miss Wong, SPM kita teruk sebenarnya. Oh yes, please agree with that. Your SPM is not that good actually. Alright, it's exactly the same question. Jahat gila kalau Miss Wong nak cakap tu, memang mulut copa gila. It's exactly the same question, but we are going to repeat the same question again. Doing the exact same method. Okay, saya ubah structure sahaja, saya ubah compound je. So same thing, I'm looking for the enthalpy of solution. I'm looking for the delta H solution. So macam biasa, sekali lagi kita sentiasa mula dengan apa yang kita nak. Okay. So saya ada enthalpy of solution. I start off with the enthalpy of solution. NaI solid. Forming solution. So Na plus aqueous. Sebab yang saya nak adalah solution. Aqueous. So macam biasa, letaklah label lah apa yang saya nak tu. Solution, this is what I want. Label. Okay, tak ada value. Tak payah letak value sebab saya tak tahu. Okay, next. Soalan bagi lattice energy. Soalan bagi lattice energy negative 700. So what do we do when the lattice energy is given? Saya selalu akan cakap dengan budak, tak payah tulis equation semua. Bazir masa. Nak cepat kan? So, tulis equation tu conteng kat tepi je. So, lattice energy means I have my gases ion. Alright, gases plus my I minus gases forming my NaI, solid ionic compound. Alright, gases ion forming 1 mole of solid ionic compound. That is my lattice energy. And the lattice energy is given negative 700 kilojoule. And what most important adalah tengok arrow. Jangan letak suka hati. Arrow kena betul. Arrow adalah ke arah solid. So arrow ke arah solid. Okay. Arrow ke arah solid baru boleh letak value dia negative 700. Okay. Arrow jangan salah. So you have your Na gas and also I minus gas. Okay. Slightly different over here. Apa beza soalan ni dengan soalan tadi? Adalah hydration dia bagi separate. Perasan tak? Hydration, hydration. So kita akan ada 2 value hydration guys. Kita akan ada 2 value hydration. Dan senang je, hydration saya tak payah kamu tulis equation lain pun. Hydration, my question. Gas kepada aqueous atau aqueous kepada gas? Fazana? You look boring. So let me ask you some question to spice up your evening. Ya, Fazana, guess.
Gas.
Gas to aqueous or aqueous to gas?
Gas. Gas to aqueous.
Gas to aqueous. Therefore, Fazana also, the arrow menuju ke aqueous atau arrow dari aqueous?
Toward aqueous.
Arrow towards aqueous. Setuju kelas? Arrow towards aqueous yakni negative 390 kilojoule. I minus gas kepada I minus aqueous yakni negative 307 kilojoule. Okay? Senang. Balik kepada vektor. Sebelum kita nak buat vektor, check satu benda je. Sayang, jadi cycle tak? Is everything in the form of cycle right now? Do you form a cycle? Afif, Batrisha say no. Afif, Batrisha, we do form a cycle, but we don't form a vector. It's actually a cycle. We form a cycle already, nampak? We form a cycle already. It's just the vector. Okay, we form a cycle already. So, this is the arrow that I want. This is the arrow that I want. Which arrow do I need to change at this moment?
The negative 700.
The negative 700. The negative 700 is the one that we need to change. This one adalah go against, berlanggar. This one pun go against, berlanggar. But this one is not going against. So kita tukar. Alright, kita tukar. Sarah, bila Miss Wong tukar arrow ini ke sini, what is the other changes that must come along? Sarah?
Yes, Miss.
What is the other changes that we must come along when I change the arrow?
Change the negative to positive.
We are changing the negative all the way to positive 700. Nampak? Senang? Benda ni senang dengan syarat hang boleh tulis equation. That's it. Itulah cerita dia. Alright, benda ni senang. Benda ni hang tak boleh tulis equation, hang bye-bye. Itu je. Alright, the rest of the thing is actually more on mathematics rather. Okay, plus 700. And you solve your maths. Okay. Syairan, saya nak jawapan? Saya boleh congak dapat jawapan. Syairan, can I have jawapan? Tak payah tekan, Afif. Negative 390, negative 307. So you have negative 9697. You will have a positive 3 kilojoule per mole, betul? Apa ni kan, otak tu kalau Joy balik masa meninggal, otak tu baru first hand. Macam kereta first hand yang tak ada mileage. Han tahu? Oh my god, and you're pressing your calculator for God's sake. Bila nak jadi pandai sikit? Oh, I mean you guys pandai je. Don't worry. Sila tekan calculator, it's fine. Tekan. Agree ke dengan jawapan saya yang tak tekan calculator ni?
Betul.
Agree.
You know, when the thing have a second hand value because you use it, that's why it become a second hand. But if you are going to donate your brain when you die, the receiver will be like, wow, I got a brand new brain. It's like empty, colorless, white, plain, suci. Tapi tak suci pun. Hampa kalau buat jahat nombor 1 juga. Tak jadilah. Sebab hampa buat jahat banyak. Cuma matematik je dia jadi pandai. God's sake. Alright. This is part of the
Madam.
Yes, Yasmin.
Nak tanya, kenapa kena tukar arrow?
Kenapa nak tukar arrow? Sebab kita nak, kalau kita nak buat vektor ni, sorry ya, saya nak highlight sikit. Kalau kita nak buat solution matematik ni, okay, benda yang duduk kat perkara rumus, benda yang duduk kat sini, ni, arrow dia kena bertentangan arah dengan semua arrow yang lain. So arrow ni memang bertentangan arah dah dengan dia. So tak payah ubah apalah, kamu lawan. bucu ke bucu. Yang ni pun memang bertentangan arah, kamu bucu lawan bucu. Tapi yang ni tadi asal, alright, yang ni asal macam ni. Betul? Bertentangan arah tak? Jasmine?
Tak.
Pada asal tu dia akan follow je. Dia bila follow belakang bontot dia tak boleh, dia tak jadi vektor ni. Dia tak boleh kira macam ni. Alright, so dia kena tukar supaya arrow dia duduk sini. Bila arrow dia duduk sini, barulah kita nampak bertentangan arah tu, bucu lawan bucu. Bertentangan arah means like this. Ni bertentangan arah. Okay, so bila kamu tukar arrow tu sayang, negatif kena tukar jadi positif. Barulah perkara rumus ini, data his solution, perkara rumus ini will be equals to hasil tambah semua. Mathematic, vector. That Suren say you learn in SPM. Suren people will kill you, you know. I didn't know that you learned in your SPM. I don't remember what I learned in SPM. Anyway. Okay ke, Jasmine?
Archimedes dah faham.
Okay, good. You make sure you better faham sebab kita akan jumpa balik benda ni hari Rabu. Hang tak boleh buat soalan yang saya bagi hari Rabu, hang jaga. This is part of your Hess's law. Okay? Your vector, your energy cycle method, arrow tu. Cuma masuk kat Hess's law nanti kita akan buat yang lagi banyak changes. Bukan setakat tukar arrow, mungkin number of mole pun berubah, mungkin kamu kena darab 2, kena darab separuh, kena darab 3 and so on. Okay? Boleh? So kita akan belajar lagi details pasal benda ni. Okay, if we are done, keep this. Saya ajar sebab saya nak kamu buat Hess's law sendiri sebelum hari Rabu. Okay? Saya nak kamu cuba 2.3 on your own sebelum kita jumpa hari Rabu. That's why saya ajar soalan ni. Okay? So try your 2.3 and today with another 40 minutes left, kita nak masuk calorimeter. Alright, hopefully 1-2 soalan ataupun kalau boleh 3 soalan. Calorimeter concept. Concept calorimeter, bear with me for 5 minutes, alright? Because I'm going to finish the concept in about 10 minutes only. So jangan tertidur dalam 10 minit ni, alright? So, what is the example of calorimeter? Anybody? In your daily life, do you have any example of calorimeter? Don't have? Do you realize that I always have my coffee in my thermos? All right, this is also thermos actually, but more on a bottle version, okay? And if you realize a good thermos is, you know, you realize thermos dalam tu adalah besi. Betul? Alright, biasanya lah dia besi. And then kalau kamu pernah buat lah, kalau kamu dengar thermos, telinga dia akan nampak, dia akan ada bunyi. Alright, dia ada bunyi. That is thermos lah anyway. The next question is, why do I keep my coffee in the thermos?
To keep it warm.
To keep it warm, yes, very well. Alright, senang je soalan saya. To keep it warm, that's it. Thank you, Afif. I thought you never have warm drink in your life. Alright, so to keep it warm. Why do I want, how can my thermos keep my coffee warm? Because I will trap, ingat ya perkataan, I will trap the heat. Macam mana saya nak kekalkan air panas, saya kekal panas dalam ni supaya bila saya minum lepas 3 jam, lepas 4 jam, lepas saya menyampar kat soalan kamu dan saya minum, dia still panas. Alright? Because the heat in the water, the heat in the coffee is trapped inside the thermos. Okay? And a good thermos, soalan saya, kalau thermos tu adalah thermos yang bagus, saya tuang air panas, saya pegang dengan tangan kat luar, saya patut rasa panas atau saya tak patut rasa panas? If that is a good thermos.
Tak patut.
Saya tak patut rasa panas, betul? Kalau kamu beli thermos, cara yang nak try thermos senang je. kamu masukkan air panas, lepas tu kamu pegang dengan tangan. Kalau tangan kamu rasa panas, that is a bad thermos. Sila buang. Okay? Why I say kalau tangan kamu rasa panas, then it's a bad thermos. Sebab lepas saya tuang air panas dalam ni, dan kalau saya pegang dengan tangan dan saya rasa panas, bermakna haba dalam air dah start keluar. Haba dalam air dah start keluar dan saya dah start rasa kat tangan saya. That is a bad thermos. Okay? So a good thermos is the one that I pour in my water, saya tutup, saya pegang dengan tangan, tangan saya takkan rasa panas. One thing. Second thing, saya buka air tu lepas 72 jam. Saya buka air tu lepas 3 hari. Air tu masih panas. That is a good thermos. Okay? Because the heat remain inside the bottle, the heat remain inside the thermos. Okay? And that is the example of calorimeter. So what are we going to learn in calorimeter? We are going to learn one thing. Heat. Alright? And the symbol of the heat adalah Q. We are going to learn only one thing. Q. Alright? We want to know the heat. And you know the best thing? You only have two formula. You only have two formula. Do me one little favor. Looking at the formula, what makes these two formula different? Ada dua beza. What makes these two formula different?
This one include mass.
Naili buka mic dulu.
The first formula include mass.
The first formula include mass. Very well. Betul? Ada seorang ni dia ada mass. Ada seorang ni dia tak ada mass. Okay, yang tu yang pertama. And I say ada dua beza. And I think Afif saying the second thing. I don't know whether your school, kalau kamu kat tadika dulu kamu belajar tak menulis guna yang ni. C kecil, C besar. Do you learn this? I learned this when I was in kindergarten, and my niece and nephew learning this using iPad nowadays, using their fingers. And using their fingers because obviously they drop their pen and they lose their pen that my sister bought. Okay, don't know how many pen already she bought. And you know, kids, 5-year-old kids will never know how expensive the pencil is. So yeah, obviously they drop it and they start writing with fingers. And then I tell my sister, lain kali anak kamu masuk tadika kena tulis dengan tangan. Tulis dengan jari, tak boleh tulis dengan pen sebab dia tak nak pegang pen. The only things that he know is touch screen. So yeah, thank God. Are we still in the same generation? Thank God, Olivia say yes. Thank God, Olivia, we don't have generation gap. I know what is TikTok, even though I hate it so much, but I still know what is it. I don't play. I don't have the. I used to have a TikTok account. And I realized that it's actually taking too much of my time, so I deleted it. And I realized that it's quite useless, by the way. Where we are? Yeah, writing. The next thing adalah yang saya Afif dengar kot tadi saya cakap, saya dengar sikit. C kecil, C besar. It's actually a small letter C. Dia sebenarnya adalah C kecil. Dia sebenarnya adalah C besar. Dan beza dia adalah nama. C kecil is a specific heat capacity. C besar hanya adalah heat capacity. Okay? So ada dua cara nak detect value yang dia bagi tu C besar atau C kecil. Tengok nama ataupun I prefer, cara yang saya prefer, unit. Look at the unit is one of the easiest. Dan kenapa saya kata one of the easiest bila unit? When I look at the unit, I realize my formula kena ada mass atau tak payah ada mass. Cuba kamu tengok kalau dia C kecil. Nampak tak ada mass? Gram -1. Kalau C besar, ada tak mass? Tak ada. So automatically when I have a gram -1, I have a mass, I know my formula need to have the mass. See that? Tak payah saya nak nota, tak payah saya nak apa. I just want to go through very randomly. Okay, contoh. 9.08 times 10 to the power of joule degree Celsius. C besar, C kecil. C besar, C kecil?
C besar.
C besar. Kalau kita tahu dia C besar, rasa-rasa formula yang kamu nak guna MC delta T atau C delta T?
C delta T.
Kita akan guna C delta T. Sebab apa? Sebab saya tak ada mass. Betul? Nampak? Suren?
No, madam, I accidentally touched the hand sign.
Yeah, you all always accidentally touch something. But you never accidentally ask something. Okay, it's okay, sorry boy. Alright, kat sini kita tengok sikit. I have 1769 joule degree Celsius. Okay, C besar, C kecil?
C besar.
C besar. Afif say C besar. And Afif, MC delta T or C delta T?
C delta T.
Kita akan guna formula C delta T. The same question. Look at the same question sayang. 4.18 joule per gram per degree Celsius. Alright. C besar, C kecil? Kecuali Afif, orang lain?
kecil.
C kecil.
C kecil. Dan kalau C kecil, MC delta T or C delta T?
MC delta T.
MC delta T. Nampak? Boleh? So, it's very, very easy. That's why I say I can finish the concept in 10 minutes. Alright, kalau saya tak cerita pasal iPad tadi lah. That is the formula. And that is how you identify which formula to use. Very simple. It's either reading the question very carefully. Yang dia bagi adalah specific heat capacity atau heat capacity. Another way, selain daripada tengok dia spesifik atau tak, saya suka tengok unit. Sebab dari unit saya boleh nampak ada mass atau tak ada mass. Kalau ada gram negative 1, kalau ada gram negative 1, tak payah fikir sayang. MC delta T. Kalau tak ada gram, terus C delta T. Boleh? Okay. Next thing. Simple thing, but I don't know whether you realize or not. I asked 3 classes already and everyone give the wrong answer. Delta T kat sini. Degree Celsius or Kelvin or it doesn't matter.
Doesn't matter.
Suren say it doesn't matter. Why?
Because we want to find the differences. So we'll get the same answers either way.
Because degree Celsius and Kelvin adalah tambah 273. Saya bagi contoh yang sangat senang. Kalau 10 degree Celsius and 20 degree Celsius, the difference delta T adalah 10 degree Celsius. Betul? Saya guna 10 jadikan dia Kelvin. 273 akan jadi 283 Kelvin. Over here 293 Kelvin. Betul? Alright, tolak sayang. Tolak dapat berapa? Delta T dapat berapa? 10 Kelvin. Nampak sama? So kita kisah tak? Untuk first time ever, unit kita tak kisah kat delta T. Okay? Alright. So, kalau tak kisah, kita move on sikit. We have 2 types of calorimeter in lab. Alright? I realize that you haven't do it in your lab. Kamu tak buat lagi dalam eksperimen, kita akan buat ini sebagai eksperimen kedua. I'm so sorry that you haven't do it, but I still want to teach. We have 2 types of calorimeter. One is simple, one is bomb. Simple calorimeter is actually as simple as using polystyrene cup. You know your polystyrene? Alright, tahu tak polystyrene? Polystyrene way. That is actually your polystyrene cup. Okay? And for the simple calorimeter, is normally for neutralization process. Okay? I hope you remember delta H neutralization sentiasa negative. Betul? It's always heat release. So what are we going to do? Guys, tengok betul-betul. Sebab kamu tak belajar lagi dalam amali. What are we going to do is as simple as kita ada polystyrene cup. Kita akan masukkan acid. Kita akan masukkan base. for your neutralization. Kita akan kacau dan kita akan baca suhu thermometer. Kita akan baca temperature final. Okay? So, bila kita dah ada temperature final, kita kena ada initial. Initial kita siapa? Temperature acid, temperature base sebelum dia masuk. Okay? Soalan saya satu je. Rasa-rasa my T final will be higher or will be lower than the initial if neutralization is about releasing energy. Final lagi tinggi atau initial lagi tinggi? Syahidan?
Yang sebelum tinggi, madam. Miss.
Yang sebelum tinggi. Orang lain? Olivia?
Final.
The final should be higher
Final
than your
lagi tinggi.
initial. Olivia mata dah besar dah. Olivia kata kalau dalam kelas Syahidan mati dah. Okay? Olivia tak cakap, Miss Wong cakap. Tapi kalau kamu dalam kelas saya, Syahidan tadi, there is one moment that you have that and you are now alive. Final lebih tinggi. Kenapa final lebih tinggi? Sebab acid masuk, base masuk, neutralization berlaku, haba dibebaskan. Dan saya buat benda ni dalam calorimeter. Kenapa saya buat dalam calorimeter? Sebab saya nak simpan haba yang dibebaskan tu dalam calorimeter. I'm trapping the heat inside here. So when I trap the heat inside, then only I can measure the temperature changes. So when I measure the temperature changes, I got the maximum temperature. That is my final. Alright, that is my final. So my final should always be higher than my initial. Alright, that is how we use the simple calorimeter. Next, when you have a bomb calorimeter, this is slightly harder. Bomb calorimeter biasa kita guna untuk combustion. And why combustion? Because delta H combustion again, always negative. And what are we burning? Nampak tempat kosong ni? Kita masukkan sampel kita. That is my sample. Or my compound. Alright? My substance or whatsoever you call it lah. Substance that we want to burn. And when you burn something, what happens? Heat release. Betul? So the heat will be released to the surrounding. Haba dibebaskan. So bila haba dibebaskan sayang, nampak tak termometer? Alright? So sekali lagi Syahidan, T final will be higher or T initial will be higher? Saya ada air, sebelum pembakaran berlaku, air itu panas atau selepas pembakaran berlaku, air itu lagi panas?
Okay. Selepas akan jadi lebih panas, madam. Miss.
Thank God. Alright. So your T final will be higher than your T initial. Betul? Alright. So kenapa saya kata calorimeter senang? Because it's always about neutralization and combustion only. Tak ada orang lain. Hanya neutralization, hanya combustion, hanya MC delta T atau C delta T. Tak ada orang lain. Senang? Okay. And last but not least, before we are moving to our calculation, heat is actually a type of energy. You learn in physics. I guess you learn in physics. Can we make the energy disappear? Can we disappear when you have an energy? Can we make it disappear? Boleh tak kita mansurkan tenaga tu? No. Apa yang kita boleh buat kat tenaga? We can transform. Betul? Alright. We can transform your energy from your what do we have? From your chemical energy, we can transform to electrical energy. From the electrical energy, we can move to your kinetic energy. Sometimes from kinetic energy, we change it to electrical energy. Betul? Alright. So the only things that we can do is we transform the energy, but we cannot disappear. We cannot make the energy disappear. We can only change it to another form. Same thing. We say that the neutralization will always release heat. We say that the combustion will always release heat. Betul? So the question is, the heat released by the reaction must be absorbed by somebody. When you say neutralization release heat, okay? Haba yang dibebaskan, siapa ambil weh? You say combustion release heat, siapa ambil haba tu? There must be somebody that will going to absorb the heat. And the surrounding, there is a few type of surrounding. The surrounding can be the calorimeter itself. Hanya calorimeter tu sahaja. The surrounding can be the solution. Alright, saya ada solution. Dalam ni ada solution. So, the surrounding can be the solution. The surrounding can be the water. I might put water in my thermos. That is my water. I might put water in my calorimeter and then the water absorb the heat. Okay? So, kerja kamu satu je. Dalam topik ni, kerja kamu, dua. Kerja kamu yang pertama, formula mana yang hang nak guna? MC delta T atau C delta T, yang tu satu lah. Okay, yang tu senang je. Kerja kamu yang utama satu je. The heat release absorbed by who? That is the only thing that you need to do. The heat release, we know the heat release. The heat release right now absorbed by who? That is the only thing you need to do. Okay? So this is the thing that we are going to look at. And that's it about your calorimeter. Senang. Tak ada apa. 10 minutes discussion about the theory. Theory dia tak ada apa. Itu je lah. Okay? So going into your question. Tak buat lagi, buat sama-sama. Okay? Tengok sama-sama. Alright. Combustion. Saya suka lukis tau. Saya suka lukis sebab saya tak pandai nak imagine. Bila combustion, saya tahu saya akan guna bohm calorimeter. So simple, a very simple bohm calorimeter yang saya akan lukis macam ni je. Okay? So inside here, I have 3.5 gram of ethanol. Soalan bagi. Tempat yang saya akan bakar ethanol. Next, in a calorimeter with a heat capacity of 15.2 kilojoule degree Celsius. Ladies and gentlemen, C besar, C kecil. C besar, C kecil. Afif tak sabar nak jawab tapi Afif. Yes, Suren. Besar. Okay. C besar label calorimeter punya. Alright, C besar calorimeter punya 15.2 kilojoule degree Celsius -1. And guys, can we use kilojoule? Can we use the kilojoule? No. What do? We change it to joule. 15.2 times 10 to the power of 3 joule degree Celsius -1. Okay? Next, cause the temperature to increase from. So, the temperature increase from. Bermakna saya ada T initial 19.8 degree Celsius. Saya ada T final 26.18 degree Celsius. I want delta T. Yang besar tolak yang kecil. Can I have the delta T, Syahidan? Arif?
6.3, madam.
Syahidan kata 6.3. Very good.
6.3.
Alright, settle. So, next. Sebelum kita mula apa-apa, soalan saya. Soalan mention tak solution? Is the question mention or asking for solution? Tak ada. Soalan ada mention tak pasal water? Tak ada Soalan tak mention pasal water, soalan tak tanya pasal water. Betul? So dengan kata lain, water wujud tak? Water tak wujud. Kita akan assume dalam ni kosong. Tak ada air. Okay? The very first step is your heat released by your combustion. Alright, right now, my question. The heat release will be absorbed by who? Option kamu adalah calorimeter, solution, air. Siapa absorb heat sekarang? Ada air tak? Afif kata calorimeter. Air tak ada sayang. Air tak ada, solution tak ada. So siapa yang absorb heat? Calorimeter. Maka pertama, concept of calorimeter. Maka pertama, kena tulis. Okay? Dah decide ini, when you decided this, then only you decide your MC delta T or your C delta T. Sayang, C besar tadi. Joule degree Celsius. MC delta T or C delta T? Arif? Yang lain yang boleh buat, boleh sambung buat. Arif? MC delta T or C delta T? Hello Arif? Afiq?
C delta T.
C delta T. Put in the value of the C delta T, guys. Put in the value of your C delta T. Jangan ambil yang kilojoule. 15.2 times 10 to the power of 3. Delta T kamu adalah 6.3 degree Celsius. Masukkan sahaja. Then you should get the value. And same thing. Afiq juga. Can I have the answer?
(95760).
Unit, Afiq?
Joule degree Celsius -1. J.
Wait, heat. Heat je. Joule sahaja.
Joule.
Okay, joule sahaja. And to make your life easier, value dia besar gila kan? How can I change it to smaller? Change it to kilojoule. 95.76 kilojoule. Okay, change it to kilojoule. Then your life will be easier a bit. Okay? Can we move on? Setuju setakat ni? Alright. Next, what is the question asking for? Question asking for enthalpy of combustion. Can I have the definition of enthalpy of combustion? Ziyun? Can I have enthalpy of combustion definition? Oh, selak nota semua, duk selak nota saya nampak.
Yes, madam.
Yes?
Heat released when 1 mole of substance is burned completely.
Heat released when 1 mole of substance is completely burned. So your enthalpy of combustion will be negative when you burn 1 mole of ethanol.
Heat released when 1 mole of substance is burned completely in excess oxygen in standard conditions.
Thank you. So it's a heat release when you burn 1 mole of ethanol. Thus, I want to ask one thing. For this delta T, 6.3, do I burn 1 mole of ethanol? How much do I burn? Minrui say no. Minrui, how much do we burn?
0.0761 mole.
or you change to mole already. We only burn 3.5 gram for this delta T. Betul? Alright, and quite obvious the 3.5 is definitely not 1 mole. So what Minrui do over here is we are going to change this 3.5 gram to number of mole. And how do I change it to number of mole? We definitely need the molar mass of your ethanol. Molar mass of ethanol sebab saya pandai dan saya ingat, so saya ingat dia 46.0 gram per mole. Correct, Minrui? Pandai kan? Okay. Sebab saya malas nak tunggu kira molar mass. Boring. So, to get the number of mole, you are going to use the mass. The 3.5 gram changing to the number of mole by dividing to the molar mass. Then from that, you will then get your number of mole. Okay? So the number of mole that you get is 0.0761 mole. And this is the mole that you use to release this much of energy. So mole ratio come in. 0.0761 mole of ethanol will then release, look at my answer, sayang, negative 95.76. Negative. Kenapa negative? Heat release. Okay? And right now, saya tak nak pun 0.0761 mole tu. Saya nak banyak mana? I want 1 mole of ethanol. So I want 1 mole of ethanol is equals to how much? And the answer that you obtain over here will be your delta H combustion of ethanol. Okay? Can I have the answer? Anyone? Complete answer, by the way. Adriana?
Negative 1258.34.
0.34 je.
Joule.
Joule. Apa yang seronok sangat? Unit, we leave it to Suren. Suren, can I have the unit?
A kilojoule.
Kilojoule je. Come on, Adriana. You can do better than that, don't you?
Joule mole negative 1.
Joule mole negative 1.
Kilojoule mole negative 1.
Kilojoule mole
Kilojoule.
negative 1. And I hope you realise that bila masa kita nak letak per mole adalah depends on apa yang kamu tengah kira. Kita tengah kira untuk 1 mole of the compound. So dia adalah kilojoule per mole. And saya tukar dia kilojoule dah sayang. Salah saya lah sebab bila saya salin tu saya tak letak kilojoule kat belakang. Okay? Happy with that? I don't know whether you realise or not, but in terms of, what do we call that? In terms of concept of calorimeter, the concept of calorimeter hanya sini je. Perasan tak? Yang ni, matematik ni, mole ratio. Nampak? Sebab tu saya cakap calorimeter senang. Alright, calorimeter sangat senang. Boleh? Okay? Boleh move on? Boleh move on? Okay, kalau boleh move on. Another question. Sama, kita akan buat sama-sama. Sekali lagi kita fahamkan soalan dulu. Question 2. The combustion, again, combustion bermakna kita guna bom calorimeter lah. Saya memang suka lukis. Sebab saya tak pandai nak imagine. Saya tak pandai nak imagine dan saya malas nak imagine. Sebab biasa kalau exam saya dah tak cukup tidur. Betul tak? Okay? So, Zulaika? Question?
Madam, yang tadi tu kan? Kenapa kilojoule per mol?
Kenapa kilojoule? Kilojoule sebab kita dah tukarkan dia ke kilojoule. Daripada 95760 joule, kita tukar bahagi 1000 jadi 95.76. So kilojoule lah bahagi 1000. Okay. Dan kenapa dia per mole? Sebab yang kita kira adalah untuk 1 mole etanol. Apa-apa yang kamu kira untuk enthalpies, apa-apa yang kamu kira untuk enthalpies, dia mesti adalah per mole. Menjawab soalan? Like okay?
Okay, madam.
Alright.
Thank you,
This one,
madam.
back to our question 2. Combustion of magnesium. So magnesium duduk dalam ni ya. Oh, dia tak bagi mass. Dia suruh cari mass lah tu. Okay. Was carried out in a constant bomb calorimeter with a heat capacity. Alright. Saya tak pasti, saya tak dengar lagi suara dia. Yang saya panggil dan tak jawab tadi. Arif, I think. Arif? Afif, mana kembar ha?
Tak tahu.
Mana? Triple A saya hilang weh. Kesian kat dia. Hari Rabu soalan pertama Arif jawab. Okay. Next. Tak apalah, Afif. Si besar, si kecil. Hang kan favorite question hang. Heat capacity
C besar.
1500. C besar. So I have a C besar untuk calorimeter. Calorimeter punya. So 1500 joule per degree Celsius. Okay. The calorimeter was surrounded with 500 milliliter of water. So akhirnya air wujud. Soalan ni wujud air. So air ada. So saya pun label lah air sikit. Contoh-contoh. Air wujud. So I have water. Volume of H2O 500 milliliter. Okay, contohlah. Lukislah. So question asking for what? Question asking for the mass of magnesium used in the combustion. I'm looking for magnesium how many gram? When the delta T is given 3.48 degrees Celsius. So soalan dah bagi delta T equals to 3.48 degrees Celsius. Okay. Setuju setakat ni? Okay. Kalau setuju, let's go for the heat release in the reaction. Maka pertama kamu, heat release by the reaction right now absorbed by who? Rasa-rasa? Kita ada air, kita ada calorimeter. Soalan bagi info pasal dua-dua.
Water and calorimeter.
Yes, dua-dua akan absorb. Kalau soalan bagi, bermakna dua-dua akan absorb. The heat release will be absorbed by the water. The heat release will be absorbed by the calorimeter. Maka pertama. Okay. Second thing. Balik kepada your MC delta T dengan C delta T lah. Ada dua je formula pun hang nak pilih weh. Okay. Untuk water, saya bagi tahu siap-siap dulu. Yang ni saya nak tunjuk sekejap lagi. Untuk water, kita akan guna MC delta T. So, M untuk water, C kecil untuk water, delta T. Tambah dengan C besar untuk calorimeter, delta T. Okay? Fazana, you okay? Fazana, why look so boring? I miss you, you know? You don't miss me, ah? Alright. Apa kalau muka boring tu memang tunjuk tak tahan lah. Aku tunjuk Miss Wong, I'm boring like hell. Oh yes, we'll finish this. This will be the last question of this evening. Okay, don't worry, I will let you go. I don't really miss you that much, you know. I was very reluctant to see you also. If only I can don't see you, I will happy to not see you. Where we are? Oh, kenapa water adalah MC delta T? Dia bagi volume. Okay, dia bagi volume 500. what are we going to do is we are going to assume density of water is 1 gram per milliliter. Kalau dia tak bagi, kalau dia bagi kita gunalah. Kalau dia tak bagi, kita akan assume density water 1 terus. So the density of water, if you remember, the unit is your mass over volume in milliliter. So masukkanlah density 1, mass adalah yang kita nak cari. Alright, volume 500 milliliter. So from there, you can get the mass of water straight away, 500 gram. See that? Okay, and I will see me doing this a lot, you know. I love this.
Miss,
Yes.
kenapa yang Q absorb H2O tu guna C kecil?
Sebab yang dia bagi adalah volume. Bila dia bagi volume, kita hanya boleh tukar kepada mass. So bila kita tukar kepada mass, kita ada volume, kita boleh tukar kepada mass, bermakna mass akan wujud. Bila mass wujud, kita akan guna MC delta T. Okay? Boleh?
Okay, thank you, Miss.
Sure. Okay? So masukkanlah value sekarang. Okay. Tips also ya. Tips also tak habis lagi tips saya. That is my 500. Your C kecil untuk water standard 4.18. Saya akan bagi tahu 4.18 itu apa benda. Tambah dengan C besar 1500 just now. Delta T 3.48 as well. Sayang, C kecil untuk water kalau soalan tak bagi 4.18 gram per degree Celsius per gram. Kalau soalan tak bagi. Kalau soalan bagi, guna apa yang dia bagi. Kalau dia tak bagi, 4.18. Okay? So, press your calculator very, very correctly. I want the value. Saya nak dua-dua. Saya nak joule, saya nak kilojoule per mole. Fazana, since you look very boring just now, can I have the value of joule?
12493.2 joule.
Setuju yang lain? Surat? Syafi? Alright. So, I love to change it to kilojoule straight
Setuju,
away.
Miss.
I love to change it to kilojoule straight away because it will give you a smaller value later on. Alright, so saya akan suka tukar. Tapi dengan syarat satu lah sayang. Bila hang tukar, hang tulis lah unit kamu tu apa. Satu je lah. Hang jangan bahagi 1000 betul hang tinggal unit tu tak tulis. Yang tu saya tak suka lah. Okay. And I'm running out of space so I want to delete the density. I hope you have copy your density over here. Okay. And next, what do we do is we are going to compare with the delta H given. Simple. Soalan bagi delta H of combustion magnesium. Apa maksud delta H combustion magnesium? That means 1 mole of magnesium is burned. So kalau 1 mole of magnesium, I will then produce negative, look at the negative, 1849 kilojoule. Betul? Kalau 1 mole saya release that much. Right now, saya nak tahu how many mole of magnesium is used if I am only releasing negative 12.4932 kilojoule. Ladies and gentlemen, check unit. Check unit. Make sure you are comparing with the same unit. Please make sure you are comparing with the same unit. Okay? Aina Safia? Mic sayang, mic. Unmute.
Four 609.557.
Come again?
4609.557.
4609. Guys?
Yes.
4609 point something. Anybody else? Adiba?
$6.75.
Yes, I got that too. 6.7567 times 10 to the power of -3 mole. Betul kelas? That is the number of mole. I'm changing it to mass sebab soalan tanya mass.
Yes, Miss.
Alright, change it to mass. You know lah, darab dengan molar mass. Alright, number of mole darab dengan molar mass. So kamu akan dapat mass dia in gram. Aina kira balik ya. Please. No one should start at your mole concept. No one. Okay, saya tak ada masa nak ajar yang tu. So, you will get your mass. Kira sendirilah mass tu. Kamu dah sampai kat sini, you should be able to get your mass if you get the number of mole correct over that. I love your t-shirt, Shafi. Nice one. Okay. I used to have one when I was young. I'm still young anyway. I'm still young, not that old. Still very young, but I used to have that one when I was younger last time. Where we are? Okay. Any question at this moment? Any problem with this? No? I love doing this again and again. I love doing this sebab akan ada soalan yang di mana dua-dua kamu terpaksa guna MC delta T. Kenapa saya suka letak yang tu? Sebab bila dua-dua kamu kena guna MC delta T, it's very important to know the mass that you are taking is the mass of water or the mass of the calorimeter. Make sense? Alright? So it's very important for you to label, okay? And make sure you know the heat release is absorbed by who? Yang ni yang paling penting. That is actually the concept of your so-called calorimeter. Yang ni je konsep dia. Haba yang dibebaskan kena diserap oleh somebody. So kerja kamu satu je weh. Siapa yang serap haba saya? That's it. Okay? Miss Wong nak marah, Miss Wong kena marah somebody. So orang yang akan kena marah akan datang adalah orang yang tak buka mic langsung lepas saya panggil 2-3 kali, which is Muhammad Afiq. Okay? Yang lain tu buka mic jawab salah pun saya okay je Syahidan. Hang jawab salah tak apa, at least aku tahu hang bernafas lagi. Okay, Syahid Fazana nampak boring tak gaban, but it's fine, you're still there with me. It's fine, it's okay. Alright, so this is very important. Get this right and you are safe. And last but not least, semua di belakang hanya adalah mole concept. I hope you agree with me. This is all your semester 1. Nampak? Okay, that is all your semester 1. Okay. For this exercise, calorimeter, I think in total I have 9 or 10 questions only. So we have done 2, that is about 7 or 8 left. So try the 7 or 8 left. Ada soalan susah, saya mengaku. Try to discuss with your friend. Look at the example that I have in the notes and try to answer that. Okay? On Wednesday, I will see you with the question that you tak boleh buat. Soalan yang tak boleh buat je saya akan bincang. Dan saya nak masuk Hess's Law hari Rabu. Okay, saya nak masuk Hess's Law hari Rabu, so be prepared. And also, I want to do extra class on Thursday night. Okay, 8:30. Kalau kita akan tengok, kalau boleh saya nak masuk bond haver cycle terus malam tu, kalau Hassas Law habis. Sebab semua tutor saya akan habis hari Rabu. So saya nak tengok hari Rabu tu habis sampai mana, kita akan jumpa Khamis malam. Okay? I try very hard to do the extra class after I see you face to face. I